Okay, good morning, everybody. It's about time, so I think we should get started. Now, this is the first class or first lecture for this Advanced Physical Chemistry 1 course. And this course will be given in English. However, you are free to ask questions or when during discussion, you are free to use Chinese. It's okay because the idea of having this class in English is mainly to allowing students in the TIGP program to participate in this class. And I know that there are quite a few Taiwanese students also enrolled in this class. And if you want to ask questions in Chinese, you want to discuss in Chinese with your peers from Taiwan, I think it's okay. And I will translate the questions into English so that everybody can understand. Okay, so the key here is we need to have a common language to communicate with each other. Now, because of this COVID-19 situation, we need to start this class online. And actually, this is not my preferred mode of teaching. I think it's more efficient and it's more engaging if we can see each other face to face in in person in an in-person classroom. But however, the situation now does not allow this to happen. So to have an efficient online kind of sections, I ask you to do a few things. First, please turn on your camera so that I can see you, and we will have good discussions during the classes. So it allows us to have a more engaging scenario. So I can see you, you can see me, and I think that's fair, right? Secondly, later on, when you log in into this WebEx meeting, please use your real name. Chinese, English is both fine, okay? When you log in, so that people can recognize you and I can recognize you. I know your name, okay? And then feel free to interrupt anytime. Just you can turn on your microphone. Now the default setting in this meeting room is that everybody joining the meeting room will be muted. So your voice will be turned off, okay? But it's okay, you have the permission to turn on your voice anytime. So if you want to ask a question, you can turn on your voice, you can unmute yourself and just speak up, okay? Also, if you look at this panel, it should be on, depending on the platform. I use a Mac, so I use a Mac version. The organization of the program will be different, and people using a Windows version will see something different. But you will find some place on your maybe right-hand side panel that you can actually raise your hand. You can this program allows you to raise your hand. Okay, and that would allow me to see to hear a song, and I know people have questions, and I can actually answer the questions. Okay, so you can use this raise your hand or put down your hand thing. Try it out, okay? Give it a try. So raise your hand and then put down your hand. Try to see if you can do that. Yeah, I see people doing that already. And also you can use a chat room, okay, in this program. And you are free to put any message on the chat room, but I might not be able to see it right away because I'm normally giving lectures and I won't be able to pay attention to anything appearing in the chat room, but during the break or after the class, I will take a look. So your question posted there might be answered next time in the beginning of the class, or I can actually have a online chatting with you to sort it out. Okay. So feel like this in this classroom, I want people to engage, to participate, to to feel this is not a formal lecture, is quite informal, and you are free to ask me any questions anytime. Okay, so the plan today will be we need to I'll give you a short description of the basic content of this class, of this course. And then I will try to kind of have you practice a few things, including doing, I will sort you guys into different groups, and then we will practice group discussions. Okay, so I think we should get started actually. So let me share. Okay, so now you should be able, you should see my my screen. Okay. So welcome everybody. My name is Yuanzhong Chen. I'm from NTU Chemistry, and this is the 2021 version of this Advanced Physical Chemistry 1 course. Okay. The subtitle here is Statistical Thermodynamics. So we will teach, or in this, we will cover basic fundamental concepts of statistical mechanics in terms of describing thermodynamic states. Now, this is some basic information. Okay, this is my email. Feel free to shoot me emails anytime to ask questions or to arrange office hour for anything you want to discuss. Okay, and my office in the chemistry building, the third floor. Okay, and this is my office telephone. Normally you cannot find me on this telephone, but I very often turn it off, because if I'm having a meeting, for example, I'm teaching, so in my office, and I cannot have my telephone on to interrupt me anytime. We have an UntilCool platform, okay, and some of you might already received emails or links to this platform, and then I'll give more detailed information on this. We'll have class on Tuesday, okay, 1:20 to 3:10 in the afternoon, and Thursday this time, okay, in the early morning, okay, 9:10 to 10 o'clock, okay. Until further notice, okay, the school requires that we have at least 3 weeks of online class, but I'm still thinking about whether we want to continue this, or we will go back to in-person teaching. I don't know yet. So at this time, until further notice, we will have this online using this WebEx platform. Okay. Now, and this is the link. I think I don't need to tell you the link anymore because you are here. Okay, so it's meaningless to tell you to have you write down the link or whatever. So I can give office hours, but it's by appointment. So if you have any questions, you want to have a discussion on any subject regarding related to this course, you feel free to email me and set up an appointment for discussion. Now we will have most of the content that I am going to teach is from this David Chandler's Modern Statistical Mechanics book. Okay, this is a small book. Nowadays, you might not be able to purchase it in Taiwan, but if you look carefully, you can find the electronic version of this easily, actually. So it won't be a problem for you to have access to this book, okay? And don't ask me to provide you electronic version. I'm not allowed to do this. But, you know, look carefully. Now, Chandler's book is very concise and I think it's good. Its framework is good because it contains a very concise and actually informal. It's not really formal. Okay, it's not so mathematical. Although you might think there's many mathematics in there, but the formulation of the theories in this Chandler's book is not that mathematical. So I think it's good sort of entry-level book for students in statistical mechanics. And if you want to find more details or more technique, this is the book to look after. So MacQuarries, Statistical Mechanics. This book has much more content compared to Chandler's book. Okay, and it's much more detailed descriptions and everything. So if you want to know more details, this is the book. And I think you can buy this book in Taiwan. Okay. So, but basically, if you do not have the, I will assign homeworks from Chandler's book. So you should have David Chandler's book. Okay. And if you don't have this MacQuarries book, it's okay. It's okay. Most of the content I'm going to teach, I will provide some electronic supporting supplement materials. Now, all of you will be very concerned about the grade. So basically, we will have 2 exams, one midterm exam, one final exam. Most of the your final marks, your grading will depend on these 2 exams. So we have midterm exam on October 26th, final exam on December 21st. Okay, and each of them will constitute 40% of the final grade. Now we will have homeworks, and sometimes it will be just occasionally, but sometimes we might have a quiz in class, and also class participations that will be 20% of the final grade. Okay, and I will just use this weight for your final grade, so no adjustments of the final scores will be given. Meaning, if in the end the scores you fail, then you fail. Okay, I'm not going to say okay, the average is 60, so I'm going to normalize the grade and shift the average to 80 so that more people, more of you will pass this. No, I'm not going to do that. Okay, you get what you get. The goal of this class is to introduce you some fundamental ideas of statistical thermodynamics. And what is statistical thermodynamics? It's actually equilibrium statistical mechanics. So statistical mechanics for equilibrium states, basically. Okay, and we want you to be able to link the concept that you learned in your undergraduate physical chemistry class. I suppose all of you have passed or have experienced some kind of undergraduate PChem course that focus on thermodynamics. So you should already have a foundation of thermodynamics. Okay. But in this course, I want to provide you a sort of in traditional teaching of thermodynamics. Basically, you are given a few laws and then look at how description of physical phenomena, how some equations can be derived, quantitative equations can be derived from those laws. But here I want you provide a conceptual foundation for those thermodynamic laws. from two aspects. One is from the macroscopic phenomenological aspect. That is, if you acknowledge a few fundamental properties of equilibrium systems, like their extensiveness, like their describability with a few state variables, then you can derive from basic calculus some very important quantitative thermodynamic laws. The second aspect is to understand those thermodynamic laws from fundamental physics, from mechanics, and that's the role of statistical mechanics. So you know that PV equals to nRT can be derived from a statistical average of the properties of ideal gas system, things like that. Okay, and then we will describe a few applications, IC model to give an idea of a phase transition, electrolyte systems to give you this divide UntilCool rule. And maybe if we have a time, we will cover some random walk and stochastic processes. Okay, so the idea is to provide a foundation, and that foundation is unified for thermodynamics, and also to provide the link between the fundamental mechanics, the microscopic physical law, to the macroscopic thermodynamics. And that's statistical mechanics. And then we will give a few applications now. So we will basically cover a few things. We will review some principles of thermodynamics and introduce you this statistical method. Basically, I will introduce you this Gibbs ensemble theory. Okay, there are a few approaches for this, but I will take a simpler or conceptually more easily accessible method, and this is the Gibbs ensemble method. And then we will be able to calculate statistical properties of various systems from simple gas or liquids, and chemical systems, chemical equilibrium, and some quasi non-equilibrium phenomena. That, for example, if we want to deal with random walk, then we have a link between equilibrium and non-equilibrium phenomena. I can skip this. So basically, three sections in this class: basic thermodynamics, statistical mechanics, and chemical systems. Okay. So at this point, I have a tentative schedule like this. Because of this COVID-19 situation, we lost 2 weeks already. So this semester will be highly compact, and sometimes you might feel rushed classes, but we just have to go with it. And I suggest you to spend more time in review and preview course materials. Okay, so here we lost 2 weeks, and in this semester we have this new 16-week system. So we also lost 2 weeks. Normally in the past few years we have 18 weeks instead of 16. Okay, so it's highly shortened. And I have to compress content I want to teach, but I think we can manage that. No, there's no problem. Okay, so this week we start with some simple notions of statistical thermodynamics, just to kind of warm up. Okay, and then we will talk about the fundamental laws of thermodynamics. This kind of a review of thermodynamics, and have a discussion using based on David Chandler's conceptual picture about equilibrium and the stability for thermodynamic systems. And then we can introduce the basic statistical method and the key idea of the ensemble. Then we introduce canonical ensemble, and that allows us to now have a formal definition equation for microscopic microscopically calculate entropy, free energy functions, and so forth. And then we apply it to two simplest systems, photon gas and Harman accelerators. So this will cover fundamentals of thermodynamics, basic ensemble theory, and then application to Harman accelerators. And we have a midterm exam, okay, October 26th. It's coming very quickly, okay, and in just 1 month. Then we can go on to more applications, okay? Different particles and polyatomic gas, because we are chemists, we need statistics description of molecular systems. Okay, so this is for molecular systems. Then we can describe chemical equilibrium, and then IC model to kind of gain some idea about what happened, what occurred in phase transitions, gas systems, liquid systems, electrolytes, Brownian motion, and we have a final exam. Okay. So the later half will be more about applications to different specific systems. Okay. And this is just tentative schedule. I can change. Okay. If it does not go as smoothly as I wanted, so we can slow down and put more time on the fundamentals. It's okay. Then we skip a few of those applications. Also, if you have a specific topics that you are interested in, regarding might be related to your research, might be related to a question problem that already concerned you for many long years, you can let me know. Okay, I can actually change the topic in the later later half to to if more people are interested in another different system, biological systems, cooperative effects in biological system, for example, and I can talk about that. But you need to let me know. And now a few rules. Okay, I want you to participate. So it's okay to interrupt. If you have a question, interrupt me. It's okay to disagree with you. Many of at this level, if you tend to disagree with me, you will learn better. If you just agree with me and just memorize what I said, you learn nothing. Okay? So you need to challenge. You need to challenge the idea that I present to you. At least you need to do this challenge inside your mind. Otherwise, it's not learning. It's not learning in this. It is not learning at this level if you are not challenging what your teachers say. Okay, because in this level, the learning process is actually to integrate knowledge into your own system. At this level, at this point, you should have your own system of knowledge. You know something, you don't know something, and you know how things related to each other. Okay, and this things related to each other, this network of yours, it's just for you. It's not for everybody. Everybody have its own, have their own, have his or her own network of knowledge. And in order to actually integrate this topics, these ideas into your knowledge network, you really need to think about it using your own logical system. You need to challenge what I said. You need to think very hard to try to find holes in my reasoning. And then you can actually know, or you can actually learn the topic. Okay? So it's not just okay to disagree. Actually, you should disagree, and every time. And then if then you convince yourself that, okay, I can actually agree with this, then it became your own knowledge. And it's okay to ask questions in Chinese or Taiwanese. If you want to talk in Taiwanese, I can do that. So it's okay. Yeah. but I will rephrase the question in English so that everybody can understand it. Okay. And a lot of this material has to learn by yourself. So please do homework. And it's nice to, or it's actually more effective if you form a group and have a discussions with your friends. But in the end, you need to work by yourself. Okay. And if you encounter some barrier that you find you or your friend cannot overcome, seek help. Okay, email me, arrange an office hour. We can talk about it. Turn in homework on time. Late homework will be penalized. Basically, you will get only 50% of the points with if you turn in your homework late. And still have fun. Learning is a fun process. So have fun in this process, please. Okay. Any questions? Okay, so course materials and assignments will be posted on UntilCool. Actually, right now there's already an assignment, homework number 1, already posted. Okay, and this is the link to the UntilCool. Not all of you have restricted onto this course at this point. So some of you cannot see this just by logging into your Until account. So some of you need to use this link to this UntilCool homepage. And then it's like this. So if you, sorry, this is my view. Should okay. So this is the UntilCool platform. If you access this address, you see this, right? And this is arranged according to date, week, and the modules. So each week there's a module for something. Next week. Normally I will post course material for that module for that week only before, or I mean 1 or 2 days before the class. Okay, so you should check frequently. And you will see that there are some to-do items on the right-hand side here. So there are 2 announcements that you should take a look. Some of you might already see it. And there's homework number 1 already posted. Okay, so this is homework number 1. If you click into it, you see this file. And you can see the homework. Okay, and then if you want to turn in the homework, please use this. And I think you can. So homework will be given in a PDF file, and you should answer the questions. You can type, you can just do handwriting, it's okay, on any A4 paper, any paper, it's okay. And then you take pictures using your phone, take pictures or scan your answers, put them together into a PDF file, and then you can turn in the homework. You can upload, submit your homework here. Okay. Now let's go back here. And for each module, if I intend to use slides, I will post PDF file for my PowerPoint slides here. So actually this syllabus, that slides I just gave, talk about, presented is here. Okay. And the syllabus course information is also posted in this file. So each lecture, each week I'll have this. You can see this materials here. I might also provide some additional reading materials. So for example, for this week, if you feel like you are not familiar with some of those thermodynamic terms, I post some lecture notes that I gave in previously in a PChem course here. So this one describes basics of thermodynamic processes. So what is thermodynamic processes? what are reversible processes, what are isothermal processes, irreversible processes. Take a look. So help you to review some basic thermodynamics. Also, this week I also posted another one. This is Carnot cycle and second law. Of course, second law and Carnot cycle as a key content, very important topics in thermodynamics. So introduce what is irreversible process, as Joe expansion, Carnot cycle, and how one measure entropy, or how one define entropy, this state function from Carnot cycle, things like this. So those are these are lecture notes from some of the previous courses that I taught. I hope it might help you to review some fundamental thermodynamics. Okay, so this is UntilCool platform. We also and this is the first time I use UntilCool, so some I'm also not very familiar with it, but I will learn. Also, to facilitate participations, especially in this online mode, I cannot see you. I cannot actually monitor exactly what's going on. Okay, so I found that having you form groups and have a group discussions will be very useful, and also using some interacting kind of what is this called? I don't know. So anyway, Google Docs, Google Documents will help us to kind of have interactions and keep connections. So here, it's a link to our class log. Okay. I sent this link to many of you already, but now I will post this link again in the chat room, and you should. This link will always be the same document. So you can use later on every class, every on-time class, we will use this link as our class log. Okay. I will post it on the chat room. Okay. So if you go take a look at the chat record, you see the link, and you can click on the link and link to this class log Google document. And this is actually a shared Google document that I will post one version for every lecture. For each lecture, I will post here. So this class log will allow you to type, and everybody can see it. I can see it. So we have a few sections here. First of all, we have a question sections. So if you have any questions, instead of posting in the chat room, it's more effective if you post it here. Okay. And I can see it. So you can post your questions below here. So in this also, this. And I think it's good to have everybody have your name before your question. Okay. So something like this. So I think you can see this document now in your share screen, or even if you use the link to connect to this document, you see it right there. And then we will have group discussion topics. So every time, maybe we might not be able to do it all the time, but occasionally I will post topics, questions here for group discussion. Okay. And this is kind of to let you think about it before actually I tell you what it is. And it's very important, like I said, at this level, learning is more about how you integrate the knowledge into your own knowledge network. So you really have to challenge what I said, and you really have to think about it. And the first topic that I want you to do right now, so you at this point you need to connect to this Google Doc and do topic 1. I want to collect your name and the basic information. Okay, and I provide example here. Okay, so your name. If you have a Chinese name, please also put down your Chinese name. Yeah. So because in English name sometimes I don't know how to call you. Yeah. So something will be like this. So I want your name, your affiliation, including your department and maybe graduate students, which group you are from, and I need your email. So some of you who have not registered or have not had access to the UntilCool platform, I will later today I will add your I will add your name there. Okay. Okay. So I think that's enough time for this. So now our next step will be to assign groups. Okay. So I sort of randomly assign you to 1, 2, 3, 4, 6, 7 groups right now. Okay. Most are 3 or 4 members in each group. And at this point, I will start group discussion. So you will be assigned to different groups, okay? And then in different groups, now you should introduce you to your group members. Know each other a little bit, okay? And then go back to this phone. Rolling down, you see a topic 2. Sorry, where's topic 2? Oh, somehow it's gone. It's been deleted. No problem. Oh, something here, not deleted, but so what I want you to do is to later on you will be separated into different groups, and I want you to, we have a very limited time, but I want you to know each other and write down your group number and the name of the group members. And later on we will use this group division as our, so basically form these groups for later do group discussions later on. Okay. Today we are not going to be able to talk about to have actually have a good discussions on the later topics, but I'm going to cover this a little bit, just talk about it. Okay. So today's group discussion, originally I want you to, as a group, look up 3 laws of thermodynamics and then write down, copy paste what you see below. And I want you to do this because I want you to recognize that if you find different books, you find different sources, even different pages on Wikipedia, you see that especially for second law of thermodynamics, you see different descriptions, but they are all the same. And I want you to think about how and why they are all the same. Okay. Then I want you to kind of review a few terms within your group with your group members. What is work? What's heat? What's temperature? Energy? Equilibrium? What's microscopic? And what's reversible? Of course, those terms are defined in a thermodynamic sense. So in thermodynamics, what do those terms mean? Okay, I want you to think about it. Okay. But today we are not going to have time for this group discussion, and I want to you to go back home and think about it individually. We will not do the division of group. I want to collect your group ID and members names of for the members of the groups. Okay, so now I'll start a group discussion, and this is a breakout section. So you will be separated into a small room, and you see fewer people, and you can introduce yourself, kind of know each other, and type your group ID and your name of the group members. Okay, so I'll do it right now. So maybe you two want to click on the join breakout session.
老师，所以是我们两个一组啊？
不是，你们应该有分组，但是要按按钮，你右上角应该有一个加入分组讨论的按钮。你没看到吗？
因为我连聊天室都没有。
怎么会？你是用什么连的？
那我重新加入看看。
不是，你重新加入的话会，没关系，你重新加入，我再帮你assign。然后这一位 ，Hello。
老师都没办法加入，
所以你也是没办法加入。
对，我没有看到任何选项可以点进去。
你应该是会有一个，他叫你加入分组讨论的。等一下我再给你再加一次哦。你可以自己按吗？你应该是分组讨论6
吗？我可以先再加入吗？
你可以试看看吧。对，奇怪，那其他都已经跑出去了，怎么就你们特别有问题？杨允中，我没有看到你的
啊，
我没有看到你的那个你可以自己选加分组讨论4吗？
可是我没有看到这个选项。
你是用什么程式啊？因为我也没看到你，我连在我的那个名单里面都没看到你。
我是用 MacBook 的，我也不知道哎，不然我改用网页看看好了。
Okay, so that's a very quick demonstration of how this breakout section works. So later on, I will have you join the same group. You're not assigned a group, and later on, I will have each of you to join the same group, okay, in group discussion. So yeah. So finally, about the homework. So this is first homework. A few questions. Those are not really questions. I want you to practice a little bit. So go find some information, go back to review your mathematics since that. So it's first week, so it's just a warm-up section. Should be easy. And you should turn in your answer. Like I said, you can write down your answer. You scan or you photograph, take pictures of your answer, put them together into a single PDF file, okay, and then upload your answer to the UntilCool platform. Due date is September 5th. Okay, so normally it's 1 week or 10 days, something like that, for my homework. So type or handwrite your answers, upload a document image in a dark. Only those 3 types of files will be accepted, okay, before the due date. Upload this to UntilCool platform. So that will be what's about this class. And any questions? No? Okay. So if not, then I'll see you next week on Tuesday afternoon. Okay, and we'll continue this online mode of teaching next week, and we will start right away talking about basic notions of thermodynamics next week. Okay, so that's it for today, and stop this. Okay. So see you next week.
Okay, see